Okay, Journey, here's the last one on the test that we're going to do together. This is number 20. We have to find the graph of the following and state whether there is a maximum or a minimum. So I think this is one of the ones I accidentally maybe had a choice on, so just ignore that. The first thing we're going to do, though, is we're going to try to use some process of elimination to figure out which ones show a maximum and which ones show a minimum. Actually, by looking at the graph, it looks like they all have a minimum. The vertex is at the bottom of the parabola, but let's look at the equation, because the equation is actually what tells us if it's going to have a maximum or a minimum. So if this term right here, the x squared term, is positive, which in this case it is, we know that the graph would look like this because it heads upward in a positive direction on both sides, and the vertex would be at the bottom of the graph, and so we're looking at a minimum, there we go, graph. And so let's look at these down at the bottom here. This one says it's a minimum. This one says it's a minimum. This one says it's a maximum. And the last one says it's a maximum. Well, since we've already established that the graph will have a minimum on it, we are going to omit the last two graphs here. So let me get rid of those boxes so they don't stick. I'm just going to go ahead and omit these. We're going to just delete them out of there. And that way they won't be in our way. So we're looking at one of these two graphs. Now, we can probably get to a certain point in the problem and make the determination of which one of those graphs is correct, but we're going to work through the process because that's how we were doing the problems before. So I'm going to put a line right here, and I'm going to rewrite this equation. Y equals x squared plus 5x plus 6. And we're going to pull out of there. We know we're going to need to have our A, B, and C terms. So we're going to grab, I'm going to put it in a different color for us so they stand out. So A is going to be 1, B is going to be 5, and C is going to be 6. So the process of what we're going to do here, we're going to graph our own, and then we're going to compare our graph to pick the right one. But, excuse me, in order to do the graph, we have to find a couple of things. The first thing we need to know is the vertex. If you look at these graphs over here to the left, the vertex is at which point on the graph takes a turn. And so we're looking to find where that point actually is. You're going to notice on the first graph, the vertex is, and the whole graph actually, is to the left of the y-axis, and on the second graph, it's to the right of the y-axis. So only one of those is correct. Now, quite honestly, once we establish our vertex, we can probably narrow it down and figure out which graph it is. But I want to make sure you know how to work through the whole problem. So let's go ahead and start that. So the first thing we're going to do is we're going to find the vertex. And we know that in order to find the x value of the vertex, we use this little formula. X equals a negative b over 2a. So we're going to plug in our parts to this. We have a negative 5 over 2 times 1, so we have negative 5 halves. You can leave it like that. We can make it negative 2.5. We can make it negative 2.5. Whatever you want to use there for your x value. I chose to use the decimal, just because I find that easier in my calculator than trying to use a fraction. So that's the x value. How do I find the y value? Well, I'm going to pull down my original equation of x squared plus 5x plus 6. And I'm going to take that x value that I found of negative 2.5, and I'm going to plug it into every x that I see in my original equation. So we're going to have negative 2.5 squared plus 5 times negative 2.5 plus 6. And we'll do the math on that, and we end up with y equals, this is 6.25. This will give us a negative 12.5 plus 6. And we end up with this value at the end, a negative 0.25. And if you wanted, you could say it's a negative 1/4. But I'm going to use, again, as I said, I'm going to use the decimal value because I can put that in my calculator a lot easier. So my vertex turns out to be negative 2.5 and negative 0.25. So I can already look at the graph and establish which graph is the correct one. Can you? But I want to keep going because I want you to understand how we're supposed to solve this thing. So I'm going to put another line here. And the second step then is we're going to make an XY table. and we'll plug in some x values to solve for our y value. So the xy table, you remember, looks like this. And on that XY table, actually it doesn't need to be that big. I'm going to actually kind of scale it down a little bit so it's not so huge. So we have X and we have Y. Okay, and we always put our vertex right in the middle. So I'm going to put a little V right here that indicates that's where my vertex is going to go. So the vertex we established is negative 2.5 and negative 0.25. That's going to be the middle point. That is going to be the dot on the graph above, okay, where the graph actually turns in the opposite direction. So establishing the vertex is establishing that point. We want to know the points, though, that are going up on both sides of the parabola. Like up here, take a look. If I have this, and here's my vertex, I want to know some of these points so that I could actually graph it. Okay, so if I was graphing this and wasn't given all those answers above, this is how we would do that. So we're going to pick some points above the vertex and below the vertex. So I'm going to actually make them nice even numbers rather than a decimal. So normally we would go negative 1.5, but I'm just going to put a negative 2 because there will be a spot on the graph where it crosses over negative 2. So we're just going to make our math easier by picking negative 2, negative 1, and then underneath here we'll go negative 3, negative 4, where we're heading downward in the different direction here on our XY table. So let's plug those in. Where do I plug them in? I'm going to grab my original equation. I'm going to write that right up here. That's what we're going to be using to solve for our y value for these points that we're using for x. These values we're using for x. So on the first one, we would put in here the negative 1 squared plus 5 times negative 1 plus 6. And if you do all that math, you should plug that in your computer and see, or excuse me, your calculator and see, you should come out with a 2 right here. Then we're going to plug in the negative 2. And we'll square that. Plug in the negative 2. Everywhere you see an x, you need to put in negative 2. And when you put all that in your calculator, you should end up with 0, right? Because I would have 4 minus 10 plus 6, and 4 minus 10 plus 6 is 0. We don't have to do the vertex. That's already taken care of. We already know the x and the y value, so we don't need to plug in our x value to determine the y value. It's already there. The next one would be negative 3. Now, if we've done this right, oops, I forgot to put my 0 there. If we've done this right, we should end up with a 0 and a 2 down here. So let's see if we do. Down here, we should end up with a 0 and a 2 right there. But we're going to see if that actually does pan out to be true. So we're going to put a negative 3 in for x everywhere we see it. And if you do the math there, we're going to have 9 minus 15 plus 6. 9 and 6 is 15. 15 minus 15 is 0. Put it in your calculator and you will see. And then we put a negative 4 in for our final point, plus 5 times a negative 4 plus 6. And on this one, we'd end up with 16 minus 20 plus 6. So if you have 16 and 6 would be 22 minus 20 is 2. So we did, in fact, get the opposite of what's listed above. And what am I talking about when I'm saying that? I'm talking about this right here. We have 2, 0. And from the bottom up, we have 2, 0. So that's showing me that we're going to have a parabola because the points on either side of that vertex should be symmetrically intact. So if I were to graph this thing, here's what it would look like. Let me move down here and make myself a little graph. I didn't think about pulling over an actual already prepared graph with, you know, the little squares on it and so forth, but that's okay. We're going to put our, looks like everything on the x is going to be negative. So we're going to go all the way over to 4, negative 4. Here's negative 4, negative 3, negative 2, negative 1. And then we are going to go up as high as 2. So we have 1 and we have 2. That's really all we need to graph these. So let's go ahead and graph it. I'm going to use red to graph it. So we have negative 1, 2. We have negative 2, 0. Our vertex is negative 2.5 and negative 0.25, or 1/4 down. So we're going to go 2.5 to the left. That's about right here. And then 1/4 of the way down is really only about right there. And then we have negative 3, 0. And we have negative 4, 2. So that's going to be here. So you can see our graph looks like this. So if we go up and we try to figure out which one that looks like, it is to the left of the y-axis. And so it looks like the correct answer would be this one right here. The graph has a minimum and it is to the left of the y-axis. And I do hope that that makes sense. Have a wonderful weekend journey. Bye-bye.